Hi, I'm Willem, and I'm very excited to present my entry for the 2024 Cartesi Hackathon, CarteZcash. CarteZcash takes Zcash and makes it into a roll-up by running the node software directly inside the Cartesi virtual machine. So Zcash has existed for many years and is a widely trusted private cryptocurrency, but using it can be difficult, especially for newcomers needing to acquire the coins. By making it into a roll-up, this allows users to deposit ETH and have it directly enter the Zcash protocol as shielded coins, where users can then transact privately. So the way I did this is by building a system I call TinyCash. This only does the bare essentials to ensure the chain is valid. So this includes verifying the proofs in the transactions and just ensuring that the chain is valid and continuous. What it doesn't do is things like checking the proof of work or checking for different forks and things like that you'd have to deal with when there is kind of consensus involved. The other changes that I've made is that every block contains only one transaction, and there's no issuance to miners because there are no miners in this system. I instead use what was previously used to issue things to miners as the deposit and minting mechanic in the rollup. So wrapped around this TinyCash component is CarteZcash itself, which is an application that runs inside the Cartesi machine. CarteZcash deals with accepting deposit requests and transaction requests from the outside, and it also scans for when there are coins burnt inside of TinyCash, which is done by sending to a special address. When a burn is detected, it issues a withdrawal voucher back to the L1 so that you can redeem your ETH. So another thing that I really wanted to do with CarteZcash was to make it as compatible as possible with the existing Zcash wallets infrastructure. So almost all Zcash wallets use this protocol called LightWalletD, which is a gRPC protocol for essentially getting the minimal block data required to sync a wallet. And so I made this CarteZcash proxy component, which is just another Rust service which translates these requests from a wallet, from gRPC, into inspect calls that can be made to a Cartesi machine. And this is how we read the state of TinyCash and then return it back to a Zcash wallet. And so I'm going to run a demo today which basically contains all of these components. It has the wallet, a proxy, a Cartesi machine and rollup running CarteZcash, and an L1 all combined together. So up in this panel on the top left, we have the Cartesi node, and this was started up using Sonodo. So it's also running a local Anvil testnet and various other services, as well as the Cartesi RollApp node itself. In this bottom left panel, I'm running the proxy. In this bottom right panel, I'll run the wallets. I'm using a wallet called Zingo with very minor modifications made to get it to work. And up here, I'll be running our different commands. Okay, so first of all, the proxy's up and running and the node's up and running. So let's spin up our wallet. So we've got a helper command to help us do this. Okay, so you'll notice that a few things happened here. The wallet tried to sync, so it connected to the proxy. The proxy connected to the Cartesi node, and data was returned that we're synced, but we're at block 0. So let's begin by depositing some Ether into the rollup. So to do this, we need to know the address of our wallet. And this is the Zcash address in hex form. So we run this command that I've set up, which is just deposit. We paste the Zcash address, not the Ethereum address, and the amount of ETH. So let's deposit 1 ETH into the rollup. Oh. Alright, and this submits a transaction from one of the test accounts in Anvil. And you'll see that this gets picked up by the Cartesi node. So what happened here? It received a deposit request for I guess that's 100 million. So it's 100 million because that's the kind of minimal amount that Zcash can represent, called a Satoshi. So this is 1 Ether converted to its equivalent in Satoshis. It verifies the transaction and then includes a special mint transaction to a block and mines us a new block. So if we now go to our wallet and rescan, you can see that we synced up. And if we show the balance, we now have these 100 million Satoshis available in our transparent balance. So this is great. We deposited into our Zcash rollup. So the next thing we want to do is make this into a shielded balance. So our transparent balance isn't private, and if we make any transactions using this, they're publicly visible. So we want to make a transaction to shield this so that we can make private transactions. So the Zinco wallet has a command called shield all. And so this will build us a transaction. And so these are the raw bytes of the transaction. So this was the modification I made to Zinco, that instead of trying to submit this to the network, it'll actually just print the raw transactions out to the console. So now we've got this transaction, we need to send it into our Cartesi app. So we do this by making a transaction on the L1 that calls the input box contract to then send this transaction to be executed by the rollup. So we have a command to run this, which is send. Notice that this doesn't need our Zcash address at all, because this is all encoded opaquely in the transaction. So everything in the transaction is here, and everything that it needs to be mined into a block and validated. So let's send this again via the L1. Alright, and we see that this got picked up by our Cartesi node. So verifying this transaction, the very first time it takes actually quite a long time because it has to build up all of the things it needs to verify the snark, but subsequent transactions, even private ones, don't take anywhere near this long. So I'm just going to pause the video here and so you don't have to wait for it to verify. It takes maybe 1 or 2 minutes. Okay, and you'll see that TinyCash verified the transaction. So we full on verified a Zcash zero knowledge proof inside the verifiable Cartesi machine. And so now this is done, it appended a new block and finished the request. So we can rescan the wallet. And we can now see that we have spendable balance in Orchard, which is one of the shielded pools in Zcash, the newest one that uses Halo 2. Great, so now we've done that, we can transfer this around completely privately. So let's do that by starting up another wallet, and we'll send a shielded transaction. So let's start up this other wallet. You can see that it's synced to the network, but this won't have any balance. So this time, instead of copying its transparent address, let's copy its shielded pool address. So from the wallet, we'll produce a send transaction. So we'll send maybe 500,000 Satoshis. And here's the transaction. So let's send this one as well via the input box. And you'll see that this time the verification of the ZK proof is much faster once it's already kind of bootstrapped itself. Verifying transaction, and so that only took a few seconds this time, which is how long it should take for every single shielded transaction except the first one. So we can rescan this wallet, and we now have these 500,000 Satoshis successfully transferred in the fully private pool. So this was a completely private and anonymous transaction. Okay, and the final thing that you would want to do with a Zcash RollApp is actually withdraw back to the underlying L1. So we do this by transferring to a special address, which I call the Mount Doom address. So by casting your coins into Mount Doom, they vanish from the Zcash world, but this burning will be observed by CarteZcash, and it'll issue a voucher to release locked tokens on the L1. So let's send this balance to the Mount Doom address. Okay, here we go. Send to the Mount Doom address our number of Satoshis we just received. Okay, so we produced this proof of this transaction, and so we send this, but we send it with a slightly different format, because we also need to send the address which we want to receive the ether on L1. So this is withdraw. We'll withdraw into our default account on Anvil that we've just been using. So we should be able to see its balance go up. And then paste the transaction. This essentially says whatever is reported as burned by this transaction, release the corresponding number of ETH into this given address. Okay, so we mine another block, and now so you'll see that something else happened. So CarteZcash detected that 500,000 coins were burnt, and it's sending a withdraw voucher. So it sends this voucher to the DApp address with a payload, which is essentially the encoded call to the withdraw ether function. And so now the only thing left is to actually submit the voucher. And here we go. This voucher has been received. Oh, this is the excellent Cartesi wallet by Mugen Builders that I'm just borrowing for this. So this was with almost no notifications, able to work directly with my rollup and detect the vouchers, which is super cool. And so yeah, it detected this ETH transfer thing, and then we can then execute this voucher to redeem the ETH. So thank you for watching my presentation. My experience working with the toolkit, especially Sonodo for Cartesi dApps, was fantastic. Getting up and running using this tooling was nearly effortless, and it really meant that I could get stuck into the Rust code and get developing on the actual core of the idea really quickly. I was also incredibly impressed that the Cartesi machine emulator was able to verify the ZK proofs for Zcash so quickly. I estimate it was probably only twice as slow as verifying the same proofs natively, which is incredible. So thanks very much. I'm very pleased to share this project. It's been an absolute joy to work on it this last week. And yeah, thanks for watching.